All right, we're going to cover lesson 78 today, and there's two pieces or two types of problems here. And the reality is there's several ways that we're going to work these. Here's what I want you to do. I want you to get a piece of paper, and I want you to do these with me as I do them. I'm going to work one, and then I'm going to put another one up, and I'm going to work it very slowly. And I want you to try each step as we go. And if I go too fast, pause it, do this in pencil, try these with me. This is where some of this past factoring, why do we have to learn all this different factoring mess? Today is the day we're going to start using those, and then we're going to build on that all week long. We have 3 lessons. We're going to build on rational expressions. And a rational expression is basically a fraction where the numerator and denominator are both polynomials, are both terms with positive, like a coefficient and a letter with a positive exponent. Okay, they're just going to be numbers and letters in top and bottom. And we're going to learn how to simplify them today. And there's several of these that we're going to work through. This may be a bit of a longer lecture than you are used to when it comes to math. This is some higher level thinking, so we're going to just jump in with both feet. Get paper, get a pencil, and work these with me and see how we do. All right, there's going to be a lot going on here, so get some paper out, take some notes, do these with me as I'm doing them. I'm going to go slow because there's a lot happening here, and there's a couple of different types of problems using the same ideas, and so it's a lot. Don't get bogged down in it. So here's the type of problem that we're first going to see. It's going to stay simplify and state any exclusions, and then here's your problem. Okay, so you have 2 things that we're going to do. We're going to simplify, and then we'll state any exclusions. We'll come back to this in just a second. The first thing we have to do is simplify, which means we just need to get this in its simplest form. And some of these are going to be like 1 term on top and bottom. Some of these are going to be 2 terms or 3 terms, and we're going to work through all different types in this lesson. This one might be a little bit longer than you're used to for our math videos. So 2 things. Here's your first step. You need to, in this type, there's nothing really to, well, here's how we're going to cancel this out. We're going to start by spreading it all out and factoring out the greatest common factor. Okay, so what we're going to do now is simplify. And for 1 term and 1 term, we are going to basically cancel out the greatest common factor. So your first step is going to be to spread this out. Tree everything down. 2x can't get any simpler. It stays 2x. 6x squared spreads out as 2 times 3, and then xx. Now, we can see, sort of take a backtrack over here, 2 divided by 2 is 1. If those were z's, z divided by z is 1. Anything divided by itself becomes 1. So 2 divided by 2 becomes 1. X divided by x becomes 1. So on the top we have 1 times 1. On the bottom we have 1 times 3 times 1 times x, which is just 3x. So that simplifies down. And that's going to be more thinking than some of you want to do, so don't worry about the ones. Okay, just spread it out. Mark out what matches, but what you have to remember is when everything is used up or marked off, the understood 1 is still there. So step 1, cancel out what you can, spread it out, mark it out, and then put it back together. So there's the first part of this. That's the simplifying. The second part tells us to find any exclusion. So here's the thing. In mathematics, we've talked about this. It is mathematically illegal to divide by 0. Remember I showed you guys this, if you have a 0 on top, it's okay. If you have a 0 on bottom, no way. You cannot have a 0 in your denominator. So what this word means, when these problems tell you to find exclusions, you need to state any value that's going to make this unsolvable. I cannot solve a fraction with a 0 in the bottom. So what I'm going to need to do, now as we get higher on this and higher level in math, there's going to be different types of exclusions you're going to have to find. But right now, we are going to focus on what value would make my denominator 0. Why? Because it's illegal to divide by 0. I mean, you know, you're not going to go to like math jail, but you can't do it. So in order to find exclusions, we have to find what number would create a 0 on the bottom. So we're going to set the original denominator. Here's what you have to remember. You have to go back to the original denominator, not this one, not the simplified one. My kids are singing in the background, I'm sorry. Not the original, I mean not the new simplified, but the original, okay? So go back to the original denominator. The numerator is fine, it can be 0, but the bottom cannot be. So we are going to set the original denominator equal to 0. In this case, it's 6x squared. When I solve this problem, now some of you are going to look at this and instantly know the answer, and that's fine. We're going to walk through it for those who can't see it. When I solve this down, what that's going to tell me is what value x cannot be. Because when x is that value, I get a 0 in the denominator. Hopefully that makes sense. Not seeing your faces, I'm not going to know if that makes sense. But your denominator cannot be 0. When I set the denominator equal to 0, it tells me what x cannot be. So let's work through solving this. If you know the answer, just write it down. Move that 6 over. When I move it over, I divide by 6. 0 divided by 6 is 0. Now I've got to get rid of my squared, and to undo a squared, I square root both sides. Square root of 0 is 0, so x is 0. Now again, here's what that information tells me. When x is 0, then the original denominator will be 0. That is not allowed, which means x cannot be 0. If x is 0, this becomes unsolvable. So we have two answers here. Okay, we have the original simplified answer, and then we have the exclusions. So let me show you how you're going to write those two things. You're asked to simplify and state the exclusions. So you are going to write your answer like this. This is the simplified. This is the exclusion. Now I know this says x equals 0. But the reason we did that was because when x equals 0, I get a 0 denominator, which means x cannot be 0. So we're going to write it like that. That's a lot of stuff. Step 1, cancel out what you can. Spread it all out, cancel out what you can, then set your denominator equal to 0 and solve. All right, so here's our next problem. And I'm going to take a lot of pauses here. I'm going to work real slow. I'm going to give you guys a few minutes to try it before I go in. So if you're not working and you're just listening, you're going to be bored. Get a piece of paper. Do this one as I do it, okay? So the problem tells us simplify, state any exclusions. So the first thing we're going to do is simplify. You're going to do that by canceling things out. Okay, so I'm going to give you a second. Spread this out and factor or cancel out the greatest common factor. I'll give you just a second to do that. Sorry if you heard me slurp my drink. Okay, so we're going to spread this out into its prime factors, all right? 3x can't get any simpler. It stays as 3x. However, 12 can break down into its tree, 4 times 3, and then x can spread out. So what you should have is you should have 3x over 3 times 4 xx. I have 2 x's there because x squared, right? So now I need to mark out or cancel out what they have in common. 3 and 3 cancel out. X and x cancel out. And remember, when everything is used up, there's still a 1 on top. And then on the bottom, I have a 4 and an x. So I should end up with 1 over 4x. If you didn't get there, take a second and figure out how I got there. So there is the simplified, that's step one. That's my first answer, to simplify. My second thing, though, is to find any exclusions. And remember, what it means to find any exclusions is what can my bottom x not be? I cannot have a 0 denominator, so I'm going to set this equal to 0 and solve for x, and that's going to give me what x cannot be. So take a second and solve that. So I'm going to set my denominator equal to 0. 12x squared equals 0. Now some of you can look at this and see that we're multiplying everything together on the left. So obviously x can't be 0, but let's mathematically solve through, because my brain probably, while I would know that, wouldn't know that I know that while I'm working these. So in order to solve this for x, I need to move my 12 over. Divide. 0 divided by 12 is 0. To get rid of my x squared, I square root it, but I can't just square root one side. Remember, to keep things balanced, I need to do the same thing to each side, which just tells me that x equals 0. Technically, what this tells me is x cannot be 0, because if x equals 0, then my whole denominator becomes 0, and that's mathematically not allowed. So the final answer is going to be the simplified answer with a semicolon, and then what x can't be. So 1 over 4, this tells me the simplified answer. This tells me the exclusion. So that whole thing, this whole thing right here, is my answer. Okay, let's look at another type. So make sure you have that written down, and then let me show you the other concept. It's still the same concept, it's just spread out a little bit. So this is, I should have typed in the directions here. The directions are still simplify and state any exclusions. This one, though, is different because there are more than one term on both top and bottom. So this one we're going to do slightly differently. We still have to sort of spread everything out and cancel it out. However, when you have more than one term on top and bottom, when you spread it out, you do that by factoring, okay? And this is why we spent so long on factoring, is because you now have to figure out which type of factoring works. Now, I'll be honest with you here, sometimes you can't even factor things. There's no way to factor this bottom, okay? And the problem people have with this type of a lesson is that they're all going to be slightly different, in that sometimes you're going to factor the greatest common factor. Sometimes you're going to factor the perfect square. Sometimes you're going to do trinomial factoring. None of these are you going to have to use that weird box thing that we did. None of these are going to be with that x and y. These are all going to be either trinomial, perfect squares, or common factors. So that's a little bit of good news. So we're still doing the same thing in that we're still going to spread it out so we can cancel. But when there's more than one term, the way we spread it out is by factoring. Now on this top, I can see that they should have something in common. If you can't instantly see what they have in common, spread it out. 6 is 2 times 3, xx. 4 is 2 times 2, and an x. And so I can see then that I have a 2 in common, and I have an x in common. I'm going to pull that out, and I'm going to leave my leftovers inside. So what you should end up with on the top is 2x. That's what they had in common. We pulled that out, and then we were left with 3x plus 2. So you spread it out by factoring it. Then we can cancel what matches. Now here's the thing. This whole thing matches this whole thing. Everything in those parentheses match. Now I added parentheses here because here's the rule when you're dealing with expressions, which is just a more than one term stuck together with a plus or a minus sign. if they're stuck together with an addition or subtraction sign, I can't separate it. Everything has to match exactly. So I always put parentheses around things that don't have parentheses, so I can remember that I can't just, like, I can't cancel out just a 3x here because they're stuck to other pieces. They're all one thing with that addition sign. So because 3x plus 2 exactly matches 3x plus 2, I can cancel out. So what I'm left with is 2x over, remember when everything is gone, there's an understood 1, which simplifies all the way down to just 2x. Okay, so let's take a second and process what we just did. We spread it all out by factoring it. Then we canceled out what matches, and we're left with 2x. So this is that first part. This is simplify. Okay? The second thing we're going to do is we're going to find any exclusions. And remember what that means is, what can the bottom not be? So what I need to do is I need to take this bottom piece. Remember, it has to be the original problem. I'm going to set it equal to 0. 3x plus 2 equals 0. Then I'm just going to solve this. So I move my plus 2 over, becomes minus 2. Then I move my 3 over, and I divide negative 2 divided by 3. So what my second piece is x cannot be negative 2 over 3. If I plug negative 2 over 3 in right here, I'm going to end up with 0, and 0 is not allowed. Okay, so my final answer is going to be 2x, semicolon, x cannot equal negative 2/3. This is my simplified. This is my exclusions. So that is your answer. All right, so this one is another kind. I mean, it's the same thing, but this one has 3 terms in it. So we're still going to do the same thing. We're going to simplify and we're going to find the exclusion. So step 1, we've got to spread everything out. Because this is more than one term, to do that, we factor. So these are trinomials. These are 3 pieces. So I've got to figure out what can I multiply together to get 3. Well, negative 3, which is going to be 3 and 1. How can I use 3 and 1 and get to 2? It'd have to be 3 minus 1. Then I have to figure out how to get to negative 2. And the only way to get to 2 with multiplication is 2 and 1. But how do I add those and get to positive 1? It had to be 2 minus 1. So my top factors into x plus 3, x minus 1. My bottom factors into x plus 2, x minus 1. Those of you who struggle with factoring, just take your time. Here's what I can tell you. You will end up with something that matches. So if you did this and do not have something that matches, letters and signs and numbers, you factored wrong. Okay, very rarely will you be asked to simplify one of these and not be able to. So make sure you're watching your signs in grading homework and things like that. That has been the #1 issue. Most of you have the right numbers. It's just a sign issue a lot of times. So now that we've factored this, we can cancel out what matches. And in this case, I'm going to use a different color. X minus 1, x minus 1 cancels out. Technically, they become a 1, and because we're multiplying, they don't matter. So on the top, I'm left with x plus 3. On the bottom, I'm left with x plus 1. Now we need to find any exclusions. And I walked away from this for a little bit between the last problem and this problem, and when I sat back down, I realized I've been lying to you, I think. But I do not want to go back and redo all of the, what have we at, like almost 20 minutes of video. So here's what I'm going to restate something. When you're finding your exclusions, when you're factoring like this, you're kind of supposed to go back to here, to the original. But here is the thing. This is the same value as this. So use that, because when I start trying to solve x squared plus x minus 2, I then have to use a radical and square root, and then I end up with having to, because of the square root, have a positive set and a negative set, and it's chaos. So on these, do not go back to the original. When you're working these that you're factoring, you can use the factored set. So use that set, but here's the thing, you're going to break this up into two pieces to find your exclusions. You are going to do an x plus 2 equals 0 and an x minus 1 equals 0. I know that seems a little bit strange, but I promise you it's going to be easier than going back to that original equation, okay, or original denominator. So use the factored set, but there are two pieces here. You have your first set and you have your second set. So we're going to just split that into two problems, okay? And then we're going to solve them. So x, we move, let me get my pencil back up, I just put it down. Move this 2 over, becomes minus 2, move this 1 over, becomes plus. So what I end up with is x equals negative 2, x equals 1. And in reality what that means is x cannot be negative 2, x cannot be 1. We would have gotten to the same place had we used that original thing up here, but it would have taken us so much longer. So my final answer, we have to put in the correct form, is going to be your x plus 3, x plus 2, your simplified answer, and then your exclusions. Okay? We're going to put a semicolon between the simplification and the exclusions. Whoops. All right. I'm going to do another one of these real slow so you can do it with me. I'm going to work this one real slow, taking lots of breaks and pauses for you to do this one with me. So have your pencil out, and we're going to work this one together. So first of all, write this down, x squared minus x minus 12 over x squared plus x minus 6. And the first thing you need to do is spread that out. And remember, we do that by factoring. So take a second and do that on your own. All right, two numbers when multiplied together equal 12, but when added together equal negative 1. I could use 1 and 12 to get to 12. That's not going to get me to 1. I can use 6 and 2 to get to 12. That's not going to get me to 1. But 4 and 3, if I have a negative 4, I can get to negative 1. Second one then is going to be 6. How do I get to 6? Well, I can do 1 and 6. That's not going to get me to 1. Or I can use 2 and 3. And to get to a positive 1, I would need a negative 2. So 6. Negative 2 times 3 is negative 6. Negative 2 plus 3 is positive 1. So this factors out as negative 4 plus x minus 4, sorry, x plus 3, and then x plus 3 over x minus 2. Now again, if you are here and you don't have anything that matches, double check your factoring because you should always have something at this level right now that will cancel out. All right, now we can cancel what matches. And my x plus 3 matches x plus 3. So I'm left with x minus 4 over x minus 2. Hopefully you were able to get to that point. Now we have to find our exclusion. So I'm going to give you a second to do that. Okay. To do the, well, I'm throwing my pencil. To find the exclusions, we are going to take our denominator, but remember what I told you, you can use the factored denominator and set those equal to 0. So my first one is x plus 3 equals 0. Move that over and solve for x, and I have x equals negative 3. Then I'm going to take the x minus 2, set it equal to 0. Move this negative 2 over, it becomes positive. So let me clean some of this up. Makes me feel better to have it clean. My simplified answer is this. My exclusions are this, except remember it's not. So then my correct form is going to be my simplified version, semicolon, my exclusions. So the reality is the mathematics, like the arithmetic of this, is not really hard. There's just several things, and because there's so many ways to factor, you can get bogged down here. Just take your time. We're going to do one more together that I'm going to put up here, let you try by yourself, all of it, and then we'll come back and check it. All right, here's one for you to try by yourself. I'm going to have you write this down: x squared plus 6x plus 9 over x squared minus 9. Now, the top one is a trinomial. The bottom is a perfect square. So pause the video, try it all by yourself. Once you're done, come back and check it. All right, if you haven't finished, pause it and finish it. Excuse me. I'm going to just kind of work this out. When you factor this, you should have got x plus 3, x plus 3. 3 plus 3 equals 6. 3 times 3 equals 9 over x plus 3, x minus 3. Because it's a perfect square. X, x plus 3's cancel. So I'm left with x plus 3 over x minus 3. Now listen, those numbers match. X is the same, 3 is the same, but the signs are not exact. Therefore, this stays just like this. Now I need to find my exclusion. So I'm going to take my factored bottom, x plus 3, x minus 3, set that equal to 0, then solve. So x is negative 3, or x is 3, except remember it's not. So my actual answer is x plus 3 over x minus 3, semicolon, which I know looks like a J. X cannot be negative 3, x cannot be 3. So this whole, of course my handwriting's terrible, lovely thing is your answer. All right, hopefully that's making a little bit more sense, and you're going to give it a shot. All right, you're going to do number 2 and 3 on lesson 78. Number 1 we've all done. I did all of those as your examples. I think I did maybe 1 or 2 from those activities. By the way, this is from page 171 and 172. You're going to simplify all of those and give me the exclusions. If you get stuck, shoot me a quick text and we'll go from there. Don't get bogged down on these. Just do your very best, okay?